This can also be known as Q released, Q absorbed, sorry, equals negative Q released. And I gave you already some isolations that you can use. I gave you already an isolations that you can use. Sorry guys, wait. Q equals, this I gave it to you the other day. Q equals mass times Cp times delta T. And this is equal to negative mass times Cp times delta T. Now, what is the difference? Because if you take a look at both sides, they look the same. Okay? The only difference could be the negative symbol. So what's the difference? That in this side, you're going to write just information about the substance that absorbed, okay? Absorbed energy. So between the two substances here, between the copper coin and water, what substance absorbs energy, water or the copper coin?
The copper coin.
Okay, so give me a moment. I need to move this a little bit. So how is the energy transferred? Copper coin transfers energy to water, or water transfers energy to copper coin. What is the situation that happens here? A or B?
A.
Remember that I put here some extra information, okay? I'm gonna use it here. In other words, the substance with greater temperature will transfer energy to the one with less temperature. So based on that, what is the situation that occurs? A or B?
B.
Okay, who has more temperature, the water or the copper coin?
Copper.
In
Copper.
the beginning, the problem tells you a hot just means the copper coin is placed in water to cool. Okay, so that means that the copper coin is hot. Okay, so hot copper coin is placed in water. Okay, and why is that? Because you want it to well, this is placed in cold water. Okay, no, it's not updating anything. Now it is. Okay, so the copper coin is placed in water. How was the copper coin? It was hot. Okay, the reason why you place it in the water is because you want it to get it cool. Okay, so the situation here says, in other words, the substance with a greater temperature will transfer energy to the one with less temperature. Which one has greater temperature, copper coin or water?
Copper coin.
So it comes from copper coin to the water, okay? Because copper coin has more temperature. So from this situation, this allows you to know what element absorbs and what element releases. In this case, the copper coin, it was hot, and after placing it in the water, it's cool. Okay? So the situation for the copper coin is from hot to cool. Okay? So in other words, the copper coin releases or loses temperature. That, that's what happened to the copper coin. Place it in the water and it releases the temperature. But what happened to the water? From cold to warm. That's what happened to the water. It was cool, and after you place the hot copper coin in it, is warm. Okay, probably it's not hot, but it's warm. So in this case, water absorbs or gains temperature, and this allows you to put the information in the table. Okay, now what is the substance that absorbs? According to the analysis that we just did, the substance that is absorbing is the water. Okay, so absorb is for the water, and releasing is, for this case, for the copper coin. And that's how you're going to organize the data. So this is going to be the mass of water times the Cp of water times delta T of water. And this will be equal to what you have in the other side, negative the mass of the copper coin times the Cp of the copper coin times delta T of the copper coin. And from this, you can start working in the exercise. I mean, yes, you can try working without putting the information very specific, but I recommend you to do that. Okay, always analyze what substance absorbs and what substance releases energy. Okay, that's the most important step. Now, according to the problem, we need to isolate, sorry, this one, the mass of the copper coin. Okay, so let's work with this, and then in the end, we're gonna be isolating for the copper coin's mass. So let's plug in the givens that we have. For example, for water, I know that the mass of the water is 0.101 kilograms. And I know that the Cp is 4,186 joules over kilograms Celsius. And I know that the change in temperature for the water is 8 point something. I don't know it. I'm going to check. 8.39. Okay. And that's equal to what we have in the other side. Wait, okay. What do we have in the other side? We have this negative from the formula, and we have NCC, the mass of the copper coin, that multiplies the CP of the copper coin, that is, according to the data, is 387 joules over kilograms Celsius, times delta T, C, delta T of the copper coin, that is 68 degrees Celsius. Now, I want you to see something here. Again, I'm going back to the example here. So, what happens with a copper coin? Copper coin releases or loses temperature, which means that the delta T, in that case, when you have releasing or losing, should be negative, okay? Now what happens here? The problem is not giving me a negative delta T. So you have to use it. You have to put the negative. Why is that? Because the copper coin is releasing temperature or also losing temperature. So every time you have losing or releasing temperature, the delta T should be negative. So this negative, you should include it here in the formula. Negative 68 Celsius. So again, I repeat, the copper coin is the substance that is losing energy. Because is losing energy is losing temperature. If it's losing temperature, the change in the temperature should be a negative change. It could represent, or it must represent, losing temperature. So here in this case, the temperature for the copper coin that is releasing energy must be negative. That's why I put it over there. Okay, now it's time for us to perform this multiplication. 0.101 kilogram, times etc., etc., etc. How much do you get when multiplying all this?
3,547.17.
Now, what about the units? Here, kilograms with kilograms.
Joules.
Kilograms and kilograms are cancelled, and Celsius are cancelled. So the only unit remaining is here, the joules, okay, as you already said. Now, what do we have in the other side? We have this negative right here that you're not going to eliminate, and you have this multiplication. How much do you get by multiplying all that?
Negative 26,216.
Okay, now about the units. Take a look. Here, you must cancel the Celsius with the Celsius. Okay? So you have this negative from the formula and this negative from the answer. That's what you have. Negative from the formula and negative from the answer you got. And this is joules over kilograms, and this is multiplying MC. Okay, remember, we are isolating MC. But what happens here with the symbols? They're going to become positive. So this is going to be negative, and negative is going to give you positive. Really hard for me to work in this thing. So negative and negative gives you positive. So this is going to be 26,316 joules over kilograms times MC. So all this term is multiplying MC, which means that when you move it to the other side, we'll be performing a division, okay? So MC is equal to 3,547.17 joules divided by 26,316 joules over kilograms. Now, in this part, sorry, you're not seeing it. In this part, you need to cancel the joules with the joules, okay? So your MC is equal to what? How much is that division?
0.13.
0.13. Now, we're looking for the mass. So this answer should be in kilograms. But I like to write it differently, so I'm going to put it here. So MC is going to be equal to 0.13 kilograms. Now, if you have doubts on how did I get the kilograms, sorry. If you have doubts on how did I get the kilograms, I know the reason. Gosh, now it's good. Okay, if you have a doubt on how I got the kilograms, all I did was this. I am dividing these units, okay? I am dividing those units. I'm dividing joules divided by joules over kilograms. So I'm dividing fractions. So what I do is I just rewrite those joules into a fraction form by putting one as a denominator. After this, I do the sandwich. So in the top, I'm going to have joules times kilograms divided by 1 times joules, okay? This allows me to get rid of the joules. You know, 1 in the denominator can be totally ignored. So in the end, the remaining unit is just the kilogram. That's how I obtain the kilograms in my answer. Well, I don't know if you want me to leave it there, the procedure of the kilograms. I don't like how it looks, but that's how I did it. And that's it. So guys, as I told you, the class project is going to be an exposition, okay? So you will record yourself on that for both classes. So I will assign you 2 topics, one for each class, okay? Up to, if the topics are very easy, you can do 2 topics of each class. And that will be You should do it in around 5 minutes each. So you should record yourself and upload it to YouTube and send me the link. Now, for when is that? For the last week, okay? So it shouldn't be too long, but if you want me to check the exercise that you did, I can do it for you. I mean, that's something I can do for you. But the explanation is up to you, which means that if you have to create your own material, okay, like for example, calorimetry, and I'm gonna show like the time, all that, it is up to you. If you have good skills for, for edit videos, you can do all that in a video, okay? Or you can record the videos like the way I used to do it last year, okay? Putting the camera and showing the procedure and talking while um, while doing that procedure, okay? Talking and explaining the step by step. So it's not going to be too complex, but it should be good to get all the percent. And of course, I should be able to understand what you did. So you need to be organized on your steps. So look at me. I explained you everything. I explained you how to get the units. I explained you, sometimes I explain you the conversions. Sometimes I explain you, for example, balancing equation, where that is a topic from last year. But I also teach you because I know that sometimes you tend to forget. So in your video, please try to explain me everything. Assume that I don't know anything, okay? And that will be it. So as you can see, even though if it is a long process, if you are organized with the process, if you separate the two substances correctly, you shouldn't have any problem at all by getting the answer. Okay, just be careful on the isolation and in the symbol in this part. That's very important, because if you don't do that, the mass is going to be negative. If you don't do that, the mass is going to be negative, and the masses are never negative. Okay, so this is going to be it for today. Happy Easter to all of you. We still have one class. I'm just going to end the meeting. I should say that in the other class, not in this one.